The Electric Quantum Tunneling Model, a New Perspective on Temporal Energy Transmission. Author: Mohamed El-Azab. This research introduces a new theoretical framework called the Electric Quantum Tunneling Model, EQTM, which proposes that the phenomenon of quantum tunneling can occur not only at the subatomic level but also within classical electrical systems, through a temporal interaction between direct current, DC, and alternating current, AC. By mathematically describing the relationship C equals V, F, where C equals instantaneous electrical capacitance, V equals voltage, electric potential, F equals frequency, Hz. The model identifies specific moments when AC and DC voltages become equal on the same temporal axis. These equilibrium points, called temporal quantum tunnels, represent instants where energy transfer occurs without any time delay, suggesting a possible bridge between classical electromagnetism and quantum mechanics. 1. Introduction. Quantum tunneling has long been one of the most fascinating and paradoxical phenomena in modern physics. It allows a particle to pass through an energy barrier without having the required energy, as if reality itself momentarily bends its own rules. In this research, Mohamed El-Azab proposes that a similar mechanism may manifest within macroscopic electrical systems, when a direct current, DC, interacts with a sinusoidal alternating current, AC, in a shared temporal domain. This superposition creates a measurable interference pattern, simulating the tunneling effect through an electric phase equilibrium. 2. Theoretical basis. The proposed model is based on the relation C equals V, F, where C equals instantaneous electric charge or capacitance, V equals electric potential, voltage, F equals frequency, Hz. When AC and DC components overlap, their voltage curves periodically intersect. At those precise instants of voltage equality, the potential difference becomes zero, and energy transfer occurs without resistance or temporal duration. These points are defined as temporal quantum nodes, TQN, where electrical energy changes state instantaneously, effectively eliminating time. 3. Visual representation of the concept. The model can be visualized as follows. DC current right pointing arrow a constant horizontal line. AC current right pointing arrow an oscillating sinusoidal wave. Points of intersection right pointing arrow the moments of temporal quantum tunneling. These nodes act as quantum bridges within the electric field, similar to the double-slit interference pattern, but occurring on a temporal rather than spatial plane. 4. Implications and applications. 4.1 Quantum computing. This model introduces a potential foundation for electro-quantum computing, EQC, where logical states are not limited to binary, 0 and 1, but also include -1, inverse phase. Thus, a single electric qubit could represent three simultaneous states, -1, 0, +1, exponentially increasing computational density. 4.2 Communications. A form of instantaneous quantum electric communication, IQEC, could emerge, enabling near-zero latency data transmission with quantum-level security. Signals transmitted within these temporal equilibrium zones would be virtually undetectable by classical methods. 4.3 Biomedical engineering. Controlled use of these temporal tunneling points could pave the way for ultra-precise neurostimulation and bioelectrical repair systems. By applying electrical pulses at the exact moment of quantum equilibrium, it may become possible to stimulate neuronal cells with unprecedented precision and no thermal damage. 4.4 Defense and energy. The model suggests the possibility of developing instantaneous energy discharge systems, capable of releasing or absorbing energy without any measurable delay, a potential foundation for advanced defense and energy transmission technologies. 5. Discussion. The electric quantum tunneling model redefines the relationship between electricity and time. While classical physics treats electric flow as continuous in time, this framework introduces the idea that electrical transmission may oscillate between probabilistic temporal states, forming a hybrid electro-quantum field. If this hypothesis is experimentally confirmed, It could represent a unifying step between electromagnetism and quantum field theory, a point where energy, time, and probability converge. 6. Conclusion. The EQTM presents an elegant and testable hypothesis that merges classical electrical theory with the conceptual foundations of quantum tunneling. It suggests that time itself may behave as a dynamic variable within electric fields, capable of compressing, dilating, or even momentarily vanishing. This framework could mark the beginning of a new temporal electromagnetism paradigm, expanding our understanding of quantum mechanics and the fundamental structure of energy.